Hello, everyone. Today we'll be going over the rules of exponents. But before we begin, I'd kind of like to say what exponents are. So first, we're going to have a just be our normal natural number, and then an exponent is located above to the right of that whatever that number is, in this case a, and we're going to write n as our example. So with n being our exponent, it indicates how many times a would be multiplied by itself. So it'd be a times whatever amount it says. So for a real number, you guys can actually see it. We'll have 2 be our natural number as a. We're going to have it to the third power. So 3 is our exponent, which means we'd be doing 2 times 2 times 2, which would give us our answer of 8 being our total amount we got. Now, there are some rules that we'll be going over today. So our first one we'll be going over is the product rule. And this rule kind of means when you multiply two exponential expressions with the same base, you would add the exponents. So again, we'll use a, and then this time we'll use m being our exponent at the top. Again, you're multiplying them. And then a, because it's the same base with a different exponent, so we'll say n. You would do a as our base still, and then you do m plus n for our exponents. So with real numbers, we can use 2 to the third again times 2 to the fourth. You would do 2, and then you would do 3 plus 4, which would give us 2 to the seventh power in the end. Next, we'll be going over the one that's kind of like the opposite of it, which is the quotient rule. This one is when you divide two exponential expressions with the same base, you would subtract them. So again, we'll use a to the m divided by a to the n. You would do a, then m minus n. So some real numbers, this could be 5 to the 6 divided by 5 squared would make us do 5 to 6 minus 2, which would give us our final answer of 5 to the fourth power. Our next rule is power of a product rule. In this rule, you would have different numbers, so different whole numbers. So we'll have a, and we can do m still, and you'll multiply them. And we'll have b be our next natural number. However, they share the same exponent value. So in this case, you would do a, b, multiplying each other, keeping the same exponent. You could do 3 squared times 4 squared, which we would have to do 3 times 4 squared, which would give us 12 squared as our answer. Our next rule is power of a power rule. In this one, when you're raising a power to another power, you would multiply the exponents. So in this case, you just have a, and we can have m be our exponent, and you're raising it to the nth power. You would do a, and then multiply m times m. So an example of this with real numbers would be 3 squared, and then you could do raising it to the third power. So then we would do 3 times the 2 times 3, which would give us 3 to the sixth power. Only the last one we will be going over is the zero exponent rule. So in this rule, any non-zero number raised to the number of zero is equal to 1. So essentially, you would be a raised to the 0th power, and it will equal 1. That's all it is, really. So an example of this would be 7 to the 0th power, and that answer will always equal 1. However, another example of this is if you have 0 raised to the 0 power. This answer is actually not 1, it is undefined. However, now that we've learned all of our rules, I'm going to erase this bit right here. I'm going to do an example for you guys. So, if we have 2 to the 6th power times 8 to the 5th power times 16 to the 3rd power, you need to make them all the same base. And this is how you solve an equation with multiple numbers that aren't the same base and don't have the same exponents. So the solution to this is making them have the same base. So in this case, they can all become 2. They all go into 2. So we're going to make everything else become 2. So we're going to keep our 2 to the 6th. However, 2 to the 3rd, what we went over before, is 8. So you'll write 2 to the 3rd right here. And then we'll keep the exponent that was right here before. So 2 to the 5th. And then we have to do the same thing for the 16. So you do 2 to the 4th power, which would give us 16. And then again, we need this exponent again. So we'll keep the 3 up here. Now, what we've learned from the power of a power rule, you would multiply these two numbers right here. So again, we're going to just drop the 2 to the 6th. And then we would have 2 to the 15th because you're multiplying these two numbers like we learned before. And then you'll have 2 to the 12th because again, we're multiplying them. So now that we have all of them being the same base, we can go back to our product rule that we learned before. So when they're all the same base, we could add them together. So essentially, we would do 2 plus 6 plus 15 plus 12, which gives us our final answer of 2 to the 33 power. Okay, let's do some more examples that might be a little simpler and cover more of the other rules we didn't learn already. So we're going to erase this really quick. Okay, all right, now that we have all of it erased, let's write out some problems. So our first problem, let's write this one for our first example. We will do, how about 7 to the 8th power divided by 7 squared. Now, I want you guys to think of which one it looks like it would fit into. If you're looking at the quotient rule, you're right. So this is what we'll be doing since it is division. So since it is division, we have to subtract the exponents from each other. So looking at back up at our example, we have 7 as our base. That won't change. However, we have to subtract the 8 and the 2. So we have to do 8 minus 2, which would give us the product of 7 to the 6th power. Okay, let's do a few more. So another problem we could do could be 5 to the 4th power times 4 to the 4th power as well. Now I want you guys to think of which
rule it could fall into. And it actually is power of a product rule, because we are multiplying two different numbers that share the same exponent. So in this case, we have to multiply these numbers and the exponent will stay the same. So we have to do 5 times 4 to the 4th power, which gives us 20 to the 4th power. And we can do another one, such as, how about this one? How about we do 3? What would that give us? So this one would actually go into the zero exponent rule. And following what that rule is, anything pretty much to the 0th power will equal 1. So this one would just be 1. And then we can do, how about a few more? So let's do, for our 4th example, we could do 6 to the 3rd power times 6 to the 8th power. So figure out which one it would kind of belong to, and you guys can probably figure it out. And if you're looking at the product rule, you are exactly right. So in this one, they share the same base, however, they have different numbers. So then you need to add the exponents together. So in this case, you're going to do 6 times 3 plus 8, which would give us our final answer of 6 to the 11th power. And we can do about like one more. How about? So our next one, we could do, let's do 4 to the 7th power times 2. Alrighty. What do you guys think? It is this one, actually, and that's because it is going up another power. And so in this case, we have to multiply the two exponents together. So that would leave us to do 4 times 7 times 2, which would give us 4 to the 14th power. So that's kind of a little bit about exponents and some few examples of that. So I hope you guys enjoyed and learned something.